So again, the 5 steps to solve the related rate problems. First step, make a sketch. Second, ID the given information. Third, ID what you need to find. Those first 3 steps are going to be occurring just about the same time. Step 4 is to write down any equation you might need. Step 5 is to derive with respect to time. And step 6, substitute in your values and solve the problem. So drawing a picture for our problem, we have a triangle with an altitude, calling the altitude A. So the altitude, it says in the given problem, is increasing at a rate of 1 centimeters per minute, so dAdt is 1 centimeter per minute. Another given information is that the area of the triangle is increasing at a rate of 2 centimeters squared per minute, so d capital A for area, dt is equal to 2 centimeters squared per minute. Also, the altitude is 10 centimeters that was given to us. So the A for the altitude is equal to 10 centimeters, and area is 100 centimeters squared. So capital A for area is 100 centimeters squared. The question asks what's the rate at which the base of the triangle is changing. Calling the base B, we're looking for dB dt. So the formula for the area of a triangle. Formula for the area of a triangle is 1/2 base, which is b, times the altitude, which is the height, is a. Taking the derivative, dA dt is equal to 1/2. We have a product rule. So we have g, which is a, times the derivative of b with respect to time, plus the b function times the derivative of the a function with respect to time. Replacing in our values, we have 2 for dA dt. We have 10 for little a. dB dt we do not know, so that's going to be substituted in later. Value of b, need to find that, so using area is equal to 1/2 b times the height, or the altitude, which is a. We know the area is 100, we have 1/2 the base times the altitude of 10. So 5b is equal to 100, so b, the base, is equal to 20. So replacing 20 back into the problem, and replacing in d little a dt, which is 1. Now we'll solve for dB dt, which is what the problem was asking for, the rate at which the base was changing. So distributing the 1/2 to get 5 dB dt plus 10, then solving for dB dt by bringing the 10 over, we have 5 dB dt is equal to -8. And then solving for dB dt by dividing both sides by 5. We get dB dt is equal to -8/5. And since b is measured in centimeters and time is measured in seconds, minutes, our answer then is -8/5 centimeters per minute. We have a street light that is mounted to the top of a 15-foot pole, so we're drawing a street light mounted on top of a pole, identifying the pole to just be called the letter P. So we have a 15-foot tall pole as a given information, so P is equal to 15 feet. We also have a man who is 6 feet tall who's walking away from the pole, so drawing in a picture of a man, labeling that man as M, so M is equal to 6 feet tall. The light is shining down and we're going to be looking at a shadow in the problem, so to create that shadow on the ground, with the man walking at a speed of 5 feet per second along the path, so the distance the man is from the pole, we're going to use the value of x, so to find dx dt to be given as 5 feet per second. So the shadow is the s, and the tip of the shadow is the value of x and s together. So labeling the tip of the shadow is to be the value of r. The man is 40 feet from the pole, so starting off x is equal to 40 feet is another given information. The last thing is what are we looking for is how fast is the tip of the shadow moving, so dr dt is what we'll be looking for in the problem. So in this problem, it's going to help us to draw the picture again without any images, so we can see that we actually have 2 similar triangles. So putting in the values that we have, and then separate our 2 triangles to look at the large triangle compared to the smaller triangle. So setting up a ratio, we have P over M is equal to R over R minus X. And then cross multiplying, we get the equation PR minus PX is equal to MR. Then to think about the problem, what is constant and what is changing, the value of p is going to be constant because the pole will not change size. And the value of m also will be constant because the man's height will not change size. So when deriving, those are just numbers. P and m are just constants or just coefficients. So taking the derivative of PR is going to be p dr dt. Derivative of px is just p dx dt. And derivative of mr is m dr dt. Again, no product rule because p and m were constants. Replacing in the value of 15 for the pole. Replacing in dx dt to be 5. The man, which was 6 feet. And then finding what dr dt is going to be. Bringing dr dt all to the same side, we get 9 dr dt is equal to 75. Then solving for dr dt, dividing both sides by 9. Reducing to get 25/3. And the r, which is the tip of the shadow, is measured in feet. And the time is measured in seconds.